Cloud, yes. Okay. Let me. If lesson 4. 4. So there was no homework class lesson, but there will be sort of a big homework. Not very big, but there will be a big homework. Not very big homework this lesson, hopefully. Okay, O level. For how many people are in the meeting? Okay, 19. I think I should start. Lesson 4. Today we will be discussing accuracy again. Then lower and upper bounds. Okay, let me start. So last time we sort of gave the example of a balance that you went to a mall. You want to buy a golden bracelet and a watermelon. Can you remember this, guys? Okay. So we said that we have something called accuracy, and that watermelon is not measured very accurately, while a golden bracelet is measured very accurate. And I think it was, let me draw balance. Watermelon. Golden bracelet.
مكتوب الأنسر هنا. المفروض every cell in your body need oxygen to see the chemical reaction called cellular respiration. During cellular
Let me all. I mute myself. So can you hear me now? Because someone opened the mic and I muted everyone. Yes, okay. Here, I have you. And we said it needs accurate measurement. Watermelon does not need accurate measurement. Then we saw accuracy is how much of sort of you get the fine details of everything. So we said that the watermelon is about 8 kilograms. Well, the brace is about 12 grams. And like this is like 8.000 in a 1 minute. 8,000 grams. 8,000 grams. It's 12 grams. Actually, 12 point some stuff. So it's like 12. It's like 12 point some stuff because 1 gram is about 170 Saudi reals. So yeah, the gram would be very but when will you send? I'll do the homework after I finish this lesson. I'm usually free at the weekend, so I can do the homework after I finish this lesson. Hopefully, it won't be hard. Don't worry. Okay. So let's take some examples. 1 minute. Let's say rounding. So you said rounding up. We sort of this 1, 2, 3, 4, 5, 6, 7, 8, 9, 1. So this is to the nearest ones, nearest tens, nearest hundreds, thousands, ten thousands. Notice the D. Okay. This 100,000. Again, notice the D. So on the other hand, this is to the nearest tenth and hundredth, thousandth, thousandth, th, 100, 10,000. Sorry, 10,000, thousandth. So do you remember that? Remember this diagram? And we said, for example, if you wanna round up, pi is equal to 3.141529. So if we want to round it to the nearest ones. My iPad logged out. A minute, I'll rejoin again. My iPad logged out, so I'm rejoining the meeting again. Okay. So can you can hear me well now, right? Chat. Yes. Okay. Let's continue. So to the nearest 3.1 pi to the nearest hundredth, that would be 3 point. You can't see the screen. Oh, I forgot to share screen. Shall I use PDF Expert or shall I use the Apple's Note application? Because they have a very cool ruler. Can you see it now, right? Anything? Okay. 3.1415 to the nearest hundredth. I think this has a better interface, but anyway. Three point one four. Okay, good. Okay, let's take another example. I'm just making a quick revision. Let's say to the nearest hundredth, it's 3.14. 10th, 3.1, to the nearest 1, 3. Okay, let's say we have 11 players in the field. So nearest 1, nearest 10. There's an echo. I don't think there should be an echo. Is there an echo for everyone? Okay, no good. So 11 for to the nearest 10, 1. What is the answer? 11, good. Okay, to the nearest 10. Okay, good. So after that, after rounding, we discussed significant figures. Significant figures. So we said how significant figures tells you how accurately the number is presented. Okay. For example, if you are racing with your friends, did I send? I can't remember if I sent it or not, but I think I sent it. Yeah. No, I didn't. I think I forgot to send it. I'll send it everything. You will submit the homework in the Google form. Actually, I will be working on a Telegram bot, and we'll be working on a WhatsApp bot to sort of handle homework submission, handle handles a lot of everything. Because when there are too many submissions, I usually can't sort of handle this amount. But anyways, so assuming you're running with your friends, and you want to know who is faster, who is the fastest person. So you'll have a line here and another line here. You're standing here. You'll be standing 1, 2, 3. Okay, I'll try to send everything after this lesson finishes. Okay, so and we have sort of a stopwatch here. Another friend holding a stopwatch. Let me be this friend. Okay, Mr. Dao holding the stopwatch. Okay. So you start running, and I sort of try to, you start running, running, I record. Then someone sort of reaches the line first, and I recorded some time. Let's say 13 seconds, point 1 first. Are you with me, guys? Okay, so I recorded 13.1 as the time for the first one. It's good, and we're happy, and the race is done. So let's assume now we're in the Olympic Games. Okay. Olympic Games. So that is O-level math class. Okay, this is the Olympic Games. And we have another timer. And the okay, Muhammad. But try to be back quickly. So, and they start running, and the first player gets like something like 9.4. First, a minute, let me send. First player runs 100 meters in 9.4 seconds. Second player runs 100 meter in 9.4 seconds. Third player runs 100 meter in 9.4 seconds too. So how can we differentiate who's the winner? Any ideas? How can we differentiate between this and this? By milliseconds. Okay, yeah, by milliseconds. So we need more accuracy to differentiate, to know the winner. We need more accuracy, right? Therefore, more significant figures. So we said that he actually got, the first player ran in 9.48 seconds. And the second player ran, let me write it right here, 9.48 seconds. The second player ran in 9.49 seconds. And the third player ran in 9.49 seconds too. Oh, actually, they can't repeat the race. It's just one time. They race one time because you know that in the Olympic Games they use very accurate clocks, so they basically get the time very accurately. So they'll know the difference between the first two. Yeah, if for the second and third player, I will sort of need more accuracy. Be 9.491, now 9.494. So you got the point? So this is the first one. This is the second one. This is the third one. Actually, 9.48 is the world record. World record. This is the fastest person who ever ran, or let's say ever ran in the Olympics, the 100-meter race. He's very fast. He's a very fast guy, probably faster than all of us. Anyways. Okay, so you got what? So you got why we use significant figures, right? You understand how we use significant figures. Right, guys, did you understand why we use more significant figures? Okay, good. Yazan, where are you from? Oh, nice. So, yeah, we did not. I explained it in a different way, but we said the same things, but I explained it in a different way. I was searching for an example to make it clear for you, but I hope this example made significant figures clear for you. Okay. Greetings from Egypt to you, Yazan. Anyways, let's continue. So we actually, if you took in the chemistry example and you took in your sort of chemistry class, that sort of atoms react, right? Atoms, sodium react with sort of a hydroxide to give sodium hydroxide. So they sort of make a reaction, something like that. So basically, this reaction takes very little time. Very little time. So little that we measure it in something like called femtoseconds. It's like 0.10 seconds. They sort of the atoms sort of react together very quickly, but not the solution, but the atoms itself, they react with themselves very very quickly in time frames like something like that, femtoseconds. So yeah, we sometimes need more accuracy, and then we will use more significant figures. For example, this number is written to the nearest with how many significant figures? This is 3, 4, 3, 6, 8. 3, 6, 9, 10, 12, some sort of 12, 14 significant figures. Okay. Actually, 15. 15, sorry. Because 0 is a significant figure. 15 significant figures. Anyways, so let's take another example. You don't really need to understand this very much, but I like that. I prefer that you understand why do we need significant figures. Sort of, it will give you a sense of why we use them, instead of just knowing how to solve significant figure problems at the exam. We didn't really learn anything, but I think you should know what significant figures is used for, and some sort of practical applications for the significant figures. So let's take pi again, 3.141529. Write it to one significant figure. What will be the answer? 3. Okay. Okay, 3. Write it to 5 significant figures. 5. Okay, yeah. Let's say 6. Jana, it's not okay. When you write to 6 significant figures, we check out here. So 1, 2, 3, 4, 5, 6. So we'll make a line here. Is 9 greater than 5? Yes. No. Yes. No. Add 1. Do nothing. So add not 1. So 3.1415. Jana, did you understand? Jana and Muaz, did you understand, guys? Okay. Muaz, did you understand? Yes, okay, very good. Okay, let's continue. When will we decide that a number is infinite? Actually, you don't decide. An infinite number is an infinite number. Sort of, it exists as an infinite number. How can you write that a number is infinite and does not rewritten as a fraction? Actually, infinite they're well known. For example, pi is an infinite number. Pi is sort of it's not it does not end. Can be written as a fraction. Fraction. Square root of 2, square root of 3, square root of 5, square root of any prime number, square root of any prime number. They are they're well known. The numbers that cannot be written as decimals, as a fractions are well known. So, example, pi. There are sort of another thing called phi. It's called golden ratio. Golden ratio. 1.618, I think. I can't remember the exact number. But these are well-known numbers. I don't think that you need to know how to differentiate between these two numbers. Yeah, any irrational number can be written as a fraction. Any irrational number. Okay, so let's take boundaries now. Are you ready? You need a break? Go ahead. One minute. I'll try to use Apple Notes and sort of get a feedback from you. A minute. I'll stop the share, then start it again. So you can see it right? Okay, let me start. So what we saying? Upper and lower bounds. Okay. Okay. Upper and lower bounds. Okay. I think it's good now, right? Here it is. I really like the ruler, so sorry for I'm using it, but I really like it. Oh my god. Okay, I use the normal pen, upper and lower bounds. So let's assume. Remember the rounding again. Let's remember rounding up. So we have 3.141529. So we want to round it up to 1 decimal place. Round it up to 1 decimal place. What shall we do? Okay, 3.1. Very good. 3.1. So I want to ask myself a question. I want to get a range of the numbers that can be here. Range of possible numbers. So what can be rounded up to 3.1? What values? Okay, a lot of answers. So let's draw it. Let's draw it on a number line. Okay. 3.10. Three point 0. Let me zoom more. I can't do this. Have a more zoom. 3.11, 3.12, 3. Let me try get a sort of a thinner pencil. 3.15, 3.09, 3.08, 3.07, 3.06, 3.05, 3.04. 3.16. Okay, let's try. What if I round it up 3.16? Round it up. What will be the answer? Okay, 3.2. Okay, what about 3.15? What would be the answer? 3.12. Very good. 3.2. What about 3.14? 3.1. What about 3.13? 3.1, then 3.1, then 3.1, then 3.1. It's all 3.1. What about 3.09? That would be 3.1. Good. 3.108. No, 1 minute. Who said 4? Hella, why did he say 4? Hella, are you with me? Noreen, ask your question. 3.1. Hella and Noreen, are you with me? Why did you get confused, Hella? Oh, okay. So you understand everything, Hella? Okay. Noreen. Okay, no problem. 3.14, and then what about 3.07? 3.1, then 3.06. That'll be 3.12. 3.05. 3.05 is okay. 3.1. What about 3.04? 3 or 3.1, which is correct? We're rounding up to one decimal place. One decimal place. Let me get another pen. One decimal place. 3.0. Okay. So what are the range of values that can be rounded up to 3.1? Rounded up to 3.1. Okay, very good. From here to here. So can we write it as an equality? Values from 3, 1 minute. Values from 3.05, 3.14. Inequality. Okay, let's take another example. Let's sort of zoom out here. Here. Can we write 3.14921 decimal place? $3.149. So that would be 3. Okay. When we write it to one decimal place, we only see the number. 1 minute. Let me draw it very bigly, very big, a big one. 3.149. Now what we'll do, we'll sort of make a line here. We only check this number. Only check. Oh my God. Check. Check the number after desired decimal place. So I don't care about the 9. Here. I don't care about the 9, because we only need one decimal place. Did you get me? Did you get me, Amani and Ahmed? Did you get me, Amani? Okay. Ahmed, did you get me? Ahmed and Amani. Okay, good, very good. So we have all the numbers between 3.05 and 3.49999, right? All the numbers from 3.05 to up to 3.149999999. So we want to write it as an equality. Do you know what's an equality, guys? Let me get a nice color. Okay. So we will say that we will call it x, 3.1, call x, and x can be anything from 3.05 in quality mean. So in quality, sort of, we get a range. What we did here was sort of a range, right? 3.1 can any number between 3.05 and 3.14. What? Not by nothing exact, but I mean any number in this range. Any number in this range can be rounded up to 3.1. So you will make an equality. You write it as an inequality. As an inequality. So 3.05 x, and what's the upper boundary? What's the number here? Okay, let's see the diagram. We said that 3.14 will be rounded out as 3.1, right? 3.14 will be rounded up at 3.1, right? But 3.15 will be rounded up as what? 3.2. So it's somewhere here, right? So we will say here 3.5. But shall we put it equal? No. Why? Because any number less than 3.15 will be rounded to 3.1. I mean 3.149999 to one decimal place would be 3.1. But 3.150000 to one decimal place would be 3.2. So we will take any number which is less than 3.15. Did you get why it's not equal? Less than, let me mark less than. There was someone who answered incorrectly. Yazan. Okay, Yazan, did you get the idea? Yes, okay. Who else answered it incorrectly? Let me see the chat. Okay. Yazan, do you play football? Okay, good. So, let's say we have a team. How many players can be in the pitch at any point? 11, right? I'm not live on YouTube because my laptop. I am traveling and I forgot my laptop charger. So in order to go live on YouTube, I should be I should open Doom from laptop. So I don't have the laptop charger, so I can go live on YouTube. So you start the game with 11 players, right? You receive, let's say, one red card. So we have 10 players. Okay, are you with me? Guys, are you with me? Then another red card. So we have 9 players. And the third one, 8 players. A third. A fourth. 8 players. 1, 2, 3, 4. 7 players. 1, 2, 3, 4. What happens if you receive a fifth one? A fourth one. Fourth. Fifth one. What happens? Does anyone know? Oh, so Min actually knew it. The match ends. The match ends. I don't know if you lose or not, but I don't know if you lose or not, but if you receive 5 red cards, the match ends. I'm not a very good football player, but I don't know the rules, but I know that if you receive 5 red cards, then the match ends. So how many players can be actually in the match in any sort of time? Okay, we have 7. X is the number of players, and 11. So you got it? You got it, Izan? You got the inequality? So you can only have between 7 and 11 players. If you have 6, then match ends. If you have 12, it's not football. You got it? You can't have 12. It's not football. I don't know if there's any sport that can have more than 11 players in one team. I don't know. Okay, good. So you understood the inequality is right. Well, I mean, in a sort of a formal match. Okay, let's take. Let me. Let's take a nice line. So you understood inequalities. At school, okay, but usually we're talking in a sort of a formal football setting. Bit confused with the signs. What signs? Okay, the equal or not equal. So you can have 7 is valid, right? Is a valid number, right? So we will put the number of players can be equal to 7, and that would not cause the game to end, right? So we put an equal. But and 11 also is a valid number, a valid number. We can have 11 players in the field, so we put it equal. Okay, you when we take another example, you will sort of find things will sort of you will catch it up. Okay, let's take another example. Let's say. Okay, express 17 to the nearest tens. So 17 to 10 will be 20. So we want to get the range. Okay, 20. Very good. So the range of values that can be rounded up to 20 to the nearest tens. So we can draw another line. One. This 20. This is 19, 18, 17, 16, 15, 14, 21, 22, 23, 24, 25, 26. Okay. So 14 to the nearest 10 is 10. Let me get another color. It's 10. 26 to the nearest 10. Tens is 30. 25 is 30. 24 is 20. 23 is 20. So I think you got it. So we would do like that, something like that. What about 24.999 to the nearest tens? What will be the answer? 20. Okay, good. So we would take anything smaller than 25. Let me get a new color. Anything from here to moving up to 15. Anything greater than 15, including 15, when it's rounded up to the nearest tens, then it will give us 20. So you will do something like this. You will mark it, draw it, and draw a line. Then okay, 25. We will not shade. We will not shade 25 because it's not included. So the correct answer would be, okay, Kunuz, regarding your answer. So 14.9999 to the nearest tens. What would that be? To the nearest tens, not ones, tens. So then 10. So anything from 15 to 25, right? Now here's the x. Is 15 included when we round 15 to the nearest tens? Would that be 20? Guys, are with me? Is 15 included? The class today, I think we're math prayer will sort of will the call for prayer will be about 8 minutes from now. So I think it will end in sort of 8 minutes. So 15 is 15. When we round 15 to the nearest tens, will it be equal to 20, right? Yes, so we put an equal. However, 25. When round it to the nearest 10, no, it will not be equal. So anything less than 25. 24.999 is okay. 25, not okay. And 15 is okay, but 14.99 is not okay. You got my point, Kunuz? Yes. So the correct answer is 15 x 25. Very good. So let's take another example. Let me cheat the book. So let's take this one. The capacity of a swimming pool is 620 meters cubed. Correct the two significant figures. So, sorry guys, I'm actually outdoors, so the beeps, you can hear the beeps. Anyways, swimming pool capacity. Let me try to draw a swimming pool. It'll be challenging, but I'll try to do it. Oh, I'll just show like that. It'll be simple. Okay. So, swimming pool capacity is 620 meters cubed. Why is it meters cube? Volume. Okay, good. Very good. Yeah, because volume. Yes, correct. So this is two significant figures. Two significant figures. You want to know the range? What is the range of values of the volume of the swimming pool? So let me ask a question. So 620 is rounded up. to the nearest. Here we round to two significant figures. So 620 rounded up. Let me ask it in a different way. What can be rounded? Let me change the color because it's a very important question. What can be rounded up to two significant figures and give us 620? Can 614 be correct? So let's draw a number line. Here it is, the ruler. Okay. Okay, here's 620. Okay, if we round 614 to the nearest, if you want 1 minute, the prayers is on. So I have to sort of pause for a second. I'll pause until the adhan ends, okay? Okay, I'm back. So when I write 614 to two significant figures, that will be 610. 615 to two significant figures, that will be 620. 16, that will be 620. 17, 620. 18, 620. 19, 20. 20 is 20. Okay. 20. 20. So you got it, guys, right? So what's the correct range? So it's something between here, right? Let me draw it. Shall I shade 615? Yes or no? Shall I shade it? 615. Shade. Yes, okay. Then, okay, do a line here. Shall I shade 625? 625. Two significant figures equal 630. So don't shade it. No shading. Shading. Did you get me? Did you get it, Amani? Amani, did you get it? Let me do like that. These, if he told you to draw it on a number line, if he told you to draw it on a number line, then you should draw it like that. Shade and don't shade, but it's very simple. It's very simple. Okay, so the inequality would be x would be 615, then 625. Is it clear, guys? Amani, did you get it? Amani? Yes, clear. Okay, Amani got it. Very good. So if he tells you to draw on a number line, show it on a number line, then you should draw the line that I have drew and shade whatsoever included, 615, and don't shade what's not included, 625. I'll put an example in the homework, and I sort of put a question with the number line in the homework. So we're done today. I hope that the lesson was good. Probably we'll have another lesson this week, probably on Wednesday. I'll sort of put a poll on Telegram to sort of get the best time that would fit most people. I'll try to do it now. I'll try to do it after I come from matter prayers. So I'm going to pray now, and after prayers, I'll try to put the homework. Okay, I have to go. Yes, I'll send the notes. I'll send the notes. I have to go now, cause I need to catch the prayers. And was it good? Was Apple Notes better than the other program? Shall I be using Apple Notes or the other program? Apple Notes or PDF Expert? Apple Notes. Okay. Thank you very much. I'll see you soon.